Deep within the heart of Siberia, Russia, lies a vast expanse of forest known as the taiga. It is a land of unparalleled beauty and harsh extremes, where nature reigns supreme. Towering pines and larches pierce the sky, their roots anchored in the permafrost. Rivers snake through the landscape, carving their way through the endless green. The air is crisp and clean, carrying the scent of pine needles and damp earth. For centuries, the Evenki people have lived in harmony with this unforgiving environment, their lives intertwined with the rhythms of the forest. They are nomadic reindeer herders and hunters, their knowledge of the taiga passed down through generations. To them, the forest is a sacred place, a source of life and sustenance. The year is 1908. The world is on the brink of change, but in the remote reaches of Siberia, life continues at its own pace. The Evenki people move through the taiga, their reindeer their constant companions. The sun rises and sets, casting long shadows across the land. It is a time of peace, a time of quiet anticipation. But destiny, it seems, has other plans. The sun had barely risen above the horizon, painting the sky in hues of orange and pink. The air was still and cool, promising another day in the embrace of the Siberian summer. The Evenki people were beginning their daily routines, tending to their reindeer and preparing for the day ahead. Suddenly, without warning, the sky erupted in a blinding flash of light. It was as if a second sun had been ignited, casting an eerie glow across the vast expanse of the taiga. The air crackled with energy, and a strange hissing sound echoed through the forest. Animals bolted in terror, their instincts screaming danger. Birds abandoned their nests, their frantic cries adding to the growing cacophony. The Evenki people, caught in the open, shielded their eyes from the unbearable light. A sense of dread, primal and immediate, gripped their hearts. What they had witnessed, in that split second, was a force beyond their comprehension. A cosmic event that would forever alter the landscape and leave an indelible mark on history. The blinding flash was just the prelude to a cataclysm. Moments later, a deafening explosion tore through the silence of the Siberian morning. The air pressure surged violently, sending out a shockwave that radiated outwards with unimaginable force. Trees, some as thick as a man's torso, were snapped like twigs, their trunks stripped bare and tossed aside like matchsticks. The ground shook with such ferocity that even at distances hundreds of miles away, people were thrown off their feet. Windows shattered, buildings trembled, and the very earth seemed to groan in protest. At the epicenter of the blast, an enormous column of fire and smoke surged skyward, reaching miles into the atmosphere. The heat was so intense that it ignited wildfires that raged for days, consuming everything in their path. The air itself seemed to burn, filled with the acrid smell of smoke and the stench of scorched earth. The Tunguska Event, as it would come to be known, was a disaster of unprecedented scale, a raw display of nature's power that defied explanation. In the aftermath of the explosion, a stunned silence fell over the taiga. The air, thick with smoke and dust, was heavy with the smell of destruction. The once vibrant forest was now a desolate wasteland, a graveyard of splintered trees and charred earth. Word of the event spread slowly, carried by whispers and rumors. The Evenki people, deeply shaken by the experience, spoke of a visitation from the gods, a sign of their displeasure. In the outside world, news of the Siberian explosion was met with a mixture of skepticism and fascination. What had caused this cataclysmic event? Was it a meteor, a comet, or something else entirely? The answers, for now, remained elusive, hidden amidst the wreckage and shrouded in mystery. In the vast and sparsely populated Siberian wilderness, news traveled as slowly as the shifting seasons. The Evenki people, scattered across the taiga, were the first to witness the terrifying power of the Tunguska Event. Their stories remained confined to whispers and crackling fires. The initial shockwaves gave way to an unsettling silence. The Evenki interpreted the event as a sign from the spirits, a powerful omen. Gradually, as traders and hunters ventured further, news began to trickle out. Distorted accounts painted a picture of a disaster unlike anything ever witnessed before. The true extent of the devastation remained largely unknown to the outside world. The immediate aftermath of the Tunguska event painted a scene of utter devastation. Across 800 square miles, the Siberian taiga lay in ruins. Millions of trees were scorched, stripped of their branches, and toppled like dominoes. The force of the explosion left a silent testament to its power. The air, thick with smoke and the pungent odor of charred wood, hung heavy. The ground was littered with debris, splintered wood, shattered rock, and remains of wildlife. The Tunguska event left an indelible mark on Siberia, a reminder of nature's power. The first-hand accounts of the Tunguska event provided chilling glimpses into the sheer terror and awe it inspired. The Evenki people, uniquely positioned, observed the unfolding drama. One Evenki man described a blinding flash of light and intense heat. He threw himself to the ground as a deafening roar shook the earth. A farmer near Vanavara was thrown into the air by an invisible force. He landed bruised and disoriented, his ears ringing. A massive cloud of fire and smoke rose into the sky. Stories passed down painted a consistent picture of overwhelming power. The Tunguska event was a visceral, life-altering experience. Despite the scale of the Tunguska event, the initial response was muted. The event, in a remote region, failed to capture global attention. Newspapers buried the stories in their back pages. Scientists, limited by technology, were slow to grasp its significance. Rumors swirled, secret experiments, alien encounters, divine retribution. The Tunguska event remained a shrouded mystery. The world turned a blind eye to the Siberian wilderness, its secrets buried beneath fallen trees and shifting sands of time. The year 1908 faded into history, and with it, the initial shock of the Tunguska event began to dissipate. The world, it seemed, had other concerns. The rumblings of war echoed across Europe. Empires teetered on the brink of collapse. The remote Siberian wilderness, with its enigmatic explosion, seemed a world away. Scientific curiosity waned in the absence of concrete evidence. Funding for expeditions proved elusive. The Evenki people continued to whisper tales of the fiery sky. But their stories did little to penetrate scientific skepticism. The Tunguska event seemed destined to become a footnote in history. The world had turned its gaze away from the Siberian wilderness, but the mystery of Tunguska refused to be extinguished entirely. While the official channels of scientific inquiry remained largely silent, the Tunguska event took on a life of its own in the realm of speculation and conjecture. Rumors spread through the back alleys of academia, whispered in hushed tones at scientific conferences and debated in the pages of obscure journals. Some theorized a massive meteorite had struck the Siberian taiga, its impact masked by the dense forests and the passage of time. Others spoke of volcanic eruptions or subterranean gas explosions, or even a collision with a cloud of cosmic dust. The lack of a definitive explanation fueled speculation. Some whispered of secret government experiments, hinting at a world hidden beneath the surface of everyday life, a world of shadowy agencies and technological marvels unknown to the general populace. Others spoke of extraterrestrial visitors, their alien spacecraft exploding above the Siberian wilderness, leaving behind scorched earth and unanswered questions. The Tunguska event became a blank canvas for hopes, fears, and imaginations. It reflected the anxieties of a world on the cusp of change, a world where old certainties were crumbling and the future seemed fraught with both promise and peril. As the years passed, the Tunguska event gradually faded from public consciousness. World War I erupted, consuming the attention and resources of nations. Revolution swept across empires, redrawing the map of the world. The Roaring Twenties roared, ushering in an era of unprecedented social and technological change. Yet, in the depths of the Siberian taiga, the scars of the Tunguska event remained, a silent testament to the destructive power of an unknown force. The Evenki people, their lives still intertwined with the rhythms of the forest, continued to navigate the altered landscape, their oral histories keeping the memory of the event alive. The scientific community, while not entirely forgetting the Tunguska enigma, made little progress in unraveling its secrets. The logistical challenges of reaching the remote region, coupled with the political turmoil that gripped Russia in the aftermath of the revolution, presented formidable obstacles to serious research. The Tunguska event, once a source of intense speculation and debate, settled into a state of dormancy. It became a cold case, its files gathering dust in the archives of scientific institutions, a forgotten mystery waiting for a new generation of explorers and thinkers to take up the challenge. The year is 1921. Russia, still reeling from the aftershocks of revolution and civil war, is a land in flux. Yet, amidst the chaos and uncertainty, a young scientist named Leonid Kulik experiences a spark of curiosity that will ignite a lifelong obsession. Kulik, a mineralogist by training, stumbled upon a curious account of the Tunguska Event while working for the Soviet Academy of Sciences. Intrigued by the descriptions of a massive explosion, strange lights in the sky, and a devastated forest, he felt a powerful pull towards the unknown. Unlike many of his contemporaries who dismissed the Tunguska Event as a mere curiosity, Kulik recognized the potential scientific significance of the event. He envisioned a massive meteorite, perhaps carrying with it rare minerals or even clues to the origins of the solar system, lying hidden in the Siberian wilderness. Fueled by a combination of scientific curiosity and a thirst for adventure, Kulik resolved to mount an expedition to the Tunguska region. He envisioned a journey into the heart of the unknown, a quest to unravel one of the 20th century's most enduring mysteries. Securing funding and assembling a team of scientists and explorers proved to be a formidable challenge for Kulik. The Soviet government, preoccupied with more pressing concerns, initially showed little interest in funding an expedition to investigate a decade-old explosion in a remote corner of their vast territory. Undeterred, Kulik relentlessly lobbied government officials, wrote impassioned letters to scientific institutions, and gave public lectures extolling the potential significance of the Tunguska Event. His enthusiasm and determination, coupled with the growing international interest in the mystery, eventually swayed the authorities. In 1927, after years of preparation, Kulik and his team embarked on their first expedition to the Tunguska region. Their journey, a testament to human endurance and the allure of the unknown, took them on a perilous journey by train, riverboat, and finally on foot, deep into the heart of the Siberian wilderness. They faced biting insects, treacherous swamps, and the ever-present threat of wild animals, but Kulik pressed onward, driven by the belief that he was on the verge of uncovering a secret that would reshape our understanding of the universe. After weeks of arduous travel, Kulik and his team finally reached the area identified by Evenki guides as the epicenter of the Tunguska Event. What they found, however, defied their expectations and deepened the mystery surrounding the event. Instead of a massive crater, they encountered a vast expanse of flattened trees, radiating outward from a central point like spokes on a wheel. The sheer scale of the destruction was staggering. Millions of trees lay strewn across the landscape, stripped of their branches and bark, their trunks scorched and pointing away from the epicenter like silent witnesses to an invisible force. Yet, amidst this scene of utter devastation, there was no sign of the massive impact crater that Kulik had expected to find. Kulik, a meticulous scientist, documented the scene in detail, taking photographs, sketching diagrams, and collecting samples of soil, wood, and anything else that might offer clues to the nature of the event. Faced with the enigma of the missing crater, Kulik and his fellow scientists began to explore alternative explanations for the Tunguska Event. One theory posited that the explosion had not been caused by a direct impact, but rather by an airburst, the atmospheric explosion of a celestial object such as a meteoroid or comet before it could reach the Earth's surface. According to this theory, a relatively small celestial object entered the Earth's atmosphere at high speed. As it plunged through the increasingly dense layers of air, friction generated intense heat, causing the object to vaporize rapidly in a tremendous explosion. This airburst, occurring several miles above the ground, would explain the absence of an impact crater. The shock wave generated by the explosion, radiating outwards with unimaginable force, would have been responsible for the widespread flattening of trees and the other observed effects. The airburst theory, while initially met with skepticism, offered a plausible explanation for many of the puzzling aspects of the Tunguska Event. The Tunguska Event, viewed through the lens of the airburst theory, took on a new significance. It was no longer merely a curious anomaly, a footnote in the annals of unexplained phenomena. Instead, It became a stark reminder of Earth's vulnerability to cosmic impacts, a wake-up call to the potential dangers lurking in the vastness of space. Scientists, armed with new theories and data from the Tunguska Event, began to re-examine other impact events throughout Earth's history. The Chicxulub crater, a massive impact structure buried beneath the Yucatan Peninsula, provided chilling evidence of the catastrophic consequences of large-scale cosmic collisions. The Barringer crater in Arizona, a relatively well-preserved impact crater, served as a smaller but no less dramatic reminder of the destructive power of even relatively small celestial objects. The Tunguska Event forced humanity to confront its place in the cosmos, to acknowledge the ever-present threat of cosmic impacts, and to recognize the importance of scientific understanding in mitigating these risks. While the airburst theory gained widespread acceptance as the most plausible explanation for the Tunguska Event, it was not without its critics and controversies. The scientific community found itself divided over the finer points of the event, debating the size and composition of the object, the precise altitude of the explosion, and the long-term environmental consequences. Some scientists, unconvinced by the airburst theory, clung to the idea of a direct impact, arguing that the crater may have been obscured by the passage of time or hidden beneath a nearby lake. Others proposed more exotic explanations, ranging from antimatter annihilations to miniature black hole collisions, though these theories remained largely speculative and lacked supporting evidence. The lack of a definitive answer, the lingering uncertainties surrounding the Tunguska Event, only fueled the fires of scientific inquiry. New generations of researchers, armed with more sophisticated tools and technologies, continued to investigate the event, poring over old data, conducting new expeditions to the blast zone, and developing increasingly complex models to simulate the event and test various hypotheses. The Tunguska Event remained an open wound in the tapestry of scientific understanding, a constant reminder of the limits of human knowledge and the need for continued exploration and discovery. Over a century after the sky above Siberia erupted in a blinding flash of light and a deafening roar, the Tunguska Event continues to captivate our imaginations and challenge our understanding of the universe. It stands as a testament to the raw power of nature, the fragility of human civilization, and the enduring allure of the unknown. While the airburst theory, bolstered by decades of research and analysis, provides the most comprehensive explanation for the event, the Tunguska Event retains an aura of mystery. The precise nature of the object, its origin and composition, remain subjects of debate and speculation. The long-term environmental consequences of the event, both locally and globally, are still being investigated. The Tunguska Event has transcended the realm of science, becoming a touchstone in popular culture, inspiring countless works of fiction, art, and music. It serves as a cautionary tale, a reminder of the cosmic forces that shape our universe and the potential for catastrophic events to reshape our world in an instant. The Tunguska Event, even with the airburst theory holding sway, has always been a magnet for those who dare to venture beyond the accepted boundaries of scientific thought. The sheer scale of the event, coupled with the lack of a definitive, universally agreed-upon explanation, has left a void that speculation rushes in to fill. For some, the airburst theory, while plausible, isn't strange enough, doesn't fully capture the enigma of Tunguska. Could there be other forces at play, forces beyond our current understanding of physics and the cosmos? While the scientific community leans towards skepticism when it comes to fringe theories, the Tunguska Event seems to invite such speculation. It's as if the event itself dares us to think outside the box, to consider possibilities that might seem outlandish at first glance. Let's delve into some of these more unconventional explanations, keeping in mind that while they may not have the weight of scientific consensus, they nevertheless offer a glimpse into the boundless possibilities of human imagination when confronted with the truly inexplicable. One of the more intriguing alternative theories surrounding the Tunguska Event involves the concept of antimatter. Antimatter, a sort of mirror image to the matter that makes up our everyday world, possesses the peculiar property of annihilating upon contact with ordinary matter, releasing tremendous amounts of energy in the process. The idea is this: what if, instead of a meteoroid or comet fragment, a small amount of antimatter, perhaps a stray particle or a tiny chunk, collided with the Earth's atmosphere above Tunguska? The annihilation event, though involving a minuscule amount of antimatter, would release energy equivalent to a nuclear explosion, potentially explaining the observed devastation without leaving behind any substantial impact crater. While the existence of antimatter has been confirmed in laboratory settings, its presence in significant quantities in the universe remains a topic of ongoing debate and research. Detecting antimatter is notoriously difficult as it annihilates upon contact with ordinary matter, making it a fleeting and elusive phenomenon. Nevertheless, the idea of a cosmic collision between matter and antimatter playing out high above the Siberian wilderness continues to capture the imagination. Perhaps one of the most radical and mind-bending alternative explanations for the Tunguska event involves the hypothetical existence of miniature black holes. Black holes, regions of space-time where gravity is so strong that nothing, not even light, can escape, are typically associated with the deaths of massive stars. However, some theoretical physicists have proposed the existence of primordial black holes, tiny remnants of the Big Bang, which could potentially be far smaller and less massive than their stellar counterparts. These hypothetical mini black holes, some theorize, could be zipping through the universe, leaving little trace of their passage. Could it be that a microscopic black hole, perhaps no larger than an atom, passed through the Earth at the precise moment and location of the Tunguska event? The immense gravitational forces at play, even on such a small scale, could have disrupted matter and energy in the Earth's atmosphere, creating a shock wave and releasing energy in a manner consistent with the observed effects. The black hole theory, while undeniably intriguing, remains highly speculative. Nevertheless, the possibility, however remote, adds another layer of intrigue to the Tunguska enigma. No exploration of the Tunguska event would be complete without mentioning Nikola Tesla. Tesla, a brilliant inventor, is best known for his contributions to alternating current AC electricity. He dreamed of wireless power transmission and harnessing natural forces. Tesla was engaged in the construction of his Wardenclyffe Tower. Some speculate Tesla's experiments might have caused the Tunguska event, though there's no credible evidence. The most controversial explanation for the Tunguska event is extraterrestrial involvement. The idea of an alien spacecraft causing the event has been a staple of science fiction and conspiracy theories. Proponents point to the lack of a definitive impact crater, strange lights reported before the explosion, and unusual radiation patterns as evidence. Some claim to have recovered strange artifacts, though these are often dismissed as hoaxes. The extraterrestrial hypothesis, lacking concrete evidence, still fascinates, tapping into our fears and fascination with the unknown. The idea that we are not alone in the universe, and that intelligent beings may have visited our planet, has captivated the human imagination for centuries. The Tunguska event, with its mystery, fuels such speculation. While the scientific community remains skeptical, the possibility continues to fuel imaginations, wondering if we are alone in the cosmos. New technologies help us understand near-Earth object risks. Modern science sheds light on the event's mysteries. Insights into cosmic impacts refine our understanding. Advanced tools now investigate the Tunguska event. Satellites capture high-resolution images of the blast zone. Ground-penetrating radar searches for impact signs. Computer models simulate the event in detail. Virtual recreations visualize the shockwave and heat blast. Satellites provide a unique perspective on the devastation, revealing a butterfly pattern of flattened trees. This pattern offers clues about the object's trajectory. Infrared and radar data reveal hidden features. Satellite imagery has provided invaluable data. Trees, those silent sentinels, can be surprisingly eloquent witnesses to history. Their growth rings record the passage of time and environmental changes. The trees of the Tunguska region are no exception. Their rings bear witness to the cataclysmic event of 1908. Dendrochronology has played a crucial role in reconstructing the Tunguska event. By analyzing the growth rings, scientists pinpointed the exact year of the event. The tree rings tell a story of environmental disruption and recovery. Trees in the blast path show stunted growth, their rings compressed and distorted. Trees further from the epicenter show less dramatic anomalies. Recent techniques analyze the chemical composition of the wood. Detecting elements and isotopes provides clues about the event's nature. The field of genetics has joined the quest to unravel the mysteries of the Tunguska Event, offering a unique perspective on the event's long-term ecological impact. Scientists have been collecting and analyzing DNA samples from plants and animals in the Tunguska region, comparing genetic diversity and mutation rates within the blast zone. By studying these variations, researchers hope to understand how the explosion affected the local ecosystem. The resilience of life in the face of extreme change is remarkable. The most powerful tool to understand the Tunguska event is the supercomputer. These marvels perform trillions of calculations per second, creating detailed simulations of the event. Using data from eyewitness accounts, ground surveys, and atmospheric modeling, scientists input variables like size, speed, and angle. The supercomputer models the object's trajectory, heat buildup, and detonation. Simulations show the shockwave, trees flattening, and heat blast. Comparing simulations to actual damage refines models and narrows down possibilities. Supercomputers are indispensable in studying the Tunguska event, testing hypotheses, and understanding the physics behind it. We've journeyed from the heart of the Siberian wilderness to the edges of scientific understanding, exploring the Tunguska event. Over a century has passed since that fateful morning in June 1908. From Leonid Kulik's fieldwork to modern computer simulations, scientists have grappled with Tunguska. We've delved into the airburst theory, visualizing a cosmic interloper's fiery demise. We've entertained unconventional possibilities from antimatter to miniature black holes, even speculative connections to Nikola Tesla's work, and the possibility of extraterrestrial intervention. While the definitive cause remains elusive, the pursuit has broadened our understanding of the cosmos. Why haven't we accepted the scientific explanation and moved on? The mystery itself is compelling. It reminds us that we don't have all the answers. The universe still holds secrets. This drives us to keep searching and asking questions. The Tunguska event also reminds us of our place in the cosmos. It had the potential for widespread devastation. We are not immune to cosmic forces. It encourages us to contemplate the bigger picture. We are part of something grander and more mysterious. It highlights the importance of scientific inquiry and collaboration. The Tunguska event serves as a stark reminder of the threats posed by near-Earth objects. It had the potential to cause widespread destruction over a populated area. Since Tunguska, scientists have made strides in tracking hazardous asteroids. Early warning systems are being developed to provide advance notice and deflect threats. The event taught us that even small objects can pose significant threats. It underscored the importance of investing in research and international cooperation. We are the guardians of our planet, tasked with protecting it from cosmic hazards. The Tunguska event continues to beckon, its secrets still whispering through the trees. The quest to understand this enigmatic event is far from over. New generations of scientists are rising to the challenge, armed with 21st-century tools and technologies. Advances in genetics, geophysics, and computer modeling promise detailed insights. Further expeditions may uncover new evidence, perhaps even fragments of the object itself. The search itself is worthwhile, advancing our understanding of the universe. The Tunguska event stands as a testament to the enduring power of mystery. The search continues, and the answers are sure to be awe-inspiring.